All right, and with that, that wraps up the Grace Hopper New York projects. A round of applause for all the Grace Hopper students. It was excellent. And now we're going to cut to our Chicago team, Full Stack Chicago. There's 3 teams there that will be introduced by Ben Nicewander. And why don't you kick it off, Ben, and give yourself a quick introduction, and then we'll start broadcasting the TriCaster.
Great, sounds good. Hi guys, my name is Ben Nicewander, and I'm the campus director here in Chicago. So the first team that we have up is the team of Chris, Nick, and Ellie. And when brainstorming what they wanted to do for their capstone, they really wanted to explore how we use the internet to search for information. And I think that apps that teach ourselves a little bit about ourselves are oftentimes the most compelling. So some of the interesting challenges that they faced were tracking users' browser history to visualizing and analyzing that data. So without giving away too much of their project, without further ado, here is Wikiweb.
All right. Good afternoon. My name is Chris Lannis, here with my teammates Nick Lee and Ellie Sterner, and today we present our capstone project called Wikiweb. What does it mean to browse the web? What does your browsing history say about you, and how biased is the content that you read? These are some questions that Wikiweb can answer. Wikiweb is a Google Chrome extension that allows users to visualize and analyze their personal Wikipedia browsing history. When I head over to Wikipedia, Wikiweb, running in the background, will pull the page title and some of its content. Moving from page to page, Wikiweb will follow you, learning more about how you traverse the world of Wikipedia. When you click on our toolbar icon, it brings you to your personal dashboard, which displays a number of different metrics about your browsing history. As a group, we agree that complex data like browsing history, when displayed effectively, often tell compelling stories. Users can learn a lot about themselves when they examine what they've read, when they've read it, and what that content is really trying to say. Ellie will speak a little bit more about how these visuals describe.
Thank you, Chris. On the entry page, Wikiweb displays a node map. On each node represents an article that a user has viewed, and each connection represents a link between these 2 articles. For example, if a user were to have traversed between the Chicago Cubs and Theo Epstein, there would be a link joining the 2 nodes. Additionally, a user can retrace their history. Beginning with the first article that they read, a user can step through their viewing patterns, article by article, and then order in which they have been viewed. A user can go on to select multiple nodes to gather aggregate data. Once these nodes have been selected, a user can navigate to Wiki History. There they can view their reading patterns in a more linear fashion using a scatter plot. Finally, a user can navigate to Wiki Analysis, where they can view a sentiment analysis of their selected articles. Wikiweb utilizes entity extraction and sentiment analysis using a natural language processing API called Rosette. These processes identify main keywords from the articles and categorize these keywords as having a positive, negative, or neutral association. A user can then select one of the keywords to find out which articles it was mentioned. Now, Nick will go on to talk more about the implementation of these features.
Our app uses the Chrome API to collect page content, user information, and page traversal. It sends data to an Express server, stores it in a Postgres database, and presents data visualizations using the D3 JavaScript library, all built within a front-end React framework. So we took some time during the beginning of our project to answer questions such as, how do we model the non-linear nature of browsing the web while also tracking the linear order in which a user navigates the web? These conversations drove us to represent pages as nodes, link traversals as links, and page histories as an array. The structure of our Chrome extension follows a pattern similar to Redux. Our background script manages our app state, makes AJAX calls, and dispatches data along to different components upon request. This allows our background page to be our front end's single source of truth. The D3 visuals communicate user data. All colors, sizes, shapes, and positions of graphics provide meaning to the user. In doing so, the visuals tell the story of a user's intellectual curiosity.
We love our app so much so that we believe that it could easily be extended beyond the realm of Wikipedia. As implemented, very little prevents our app from being able to display a user's Facebook, YouTube, or Reddit habits. More than that, we think our sentiment analysis display could provide a provocative means of visualizing any underlying biases of various news outlets. As it stands, Wikiweb can currently be found on the Chrome Web Store, so go find us. Thank you so much. This is Wikiweb, and as we like to say, you are what you read. Thank you.
It was really great.
It's a cool project.
Yeah, it's a very good insight that our browsing history, like, we view it as a flattened list, right? But it's really very complex.
I want them to go one step further, and they have like a list of all of the places I visited, and if they could characterize each page according to some finite number of features, then they could train something to predict what the next pages I would visit are given a page with all these possible.
Yeah, that'd be very interesting to kind of cluster the nodes for all the different pages and the traversals that they've been going on based on different kind of categories.
Basically, can you make something that falls into a Wikipedia rabbit hole for me so that I can do something else?
I want to know what I want to read before I know it.